This evening's technical lecture on construction materials and embodied ecological impacts. You're going to be hearing from these three fantastic speakers in a minute, so I'm going to introduce them to you in just a second. But just before I do that, I want to say a couple of quick things about this topic by way of a bit of scene setting. The first thing is to many of you point out the obvious, I guess, to say that climate breakdown and biodiversity are completely inextricably linked. These are both about us destroying the natural world that sustains life, sustains the human race, and has done for so long. The world has experienced a more than 2/3 decline in biodiversity over the past sort of 50 years, and countries like the UK are actually amongst the worst offenders for this. The biodiversity decrease in the UK is really quite shocking when you compare it to the rest of the world. At the same time as that happening, the construction industry that we all know and love in one way or another is one of the most extractive in the world. So over half of all materials that come out of the ground go into construction every year. And if you add up the weight of all things on this planet that are made by humans, something like 90-something% of it is construction. It's buildings and it's infrastructure. So when we use this much stuff, imagine if the use of those materials was to play a role in regenerating the living world. Imagine if it did positive things for nature rather than negative things. To be able to get to that point, to be able to start designing regeneratively, we need to understand what those impacts are far more deeply than we currently do. And that's where embodied environmental impacts come in. They're also sometimes called embodied biodiversity impacts, and some people call them embodied nature. It's all the same thing. Put simply, when your materials come out of the ground and are processed into stuff that we can build out of, what are the impacts on all living things around the world, local to the site and so on, beyond just climate change, beyond just embodied carbon. So tonight we're going to get into that mindset of those broader environmental impacts. And these three speakers are going to help get you there. So I'm going to introduce them one at a time, and then they're going to present, they're going to give you a short presentation around this topic in the order that they're on the screen now. At the end of that, there'll be time for Q&A, and you can put your questions in the chat as mentioned before. So please do that as we go through. So Elsa will be speaking to you first. Elsa's a chartered civil engineer with 10 years experience as both a structural engineer and innovation consultant. And across her career, she's worked on structures of all different sorts of scales, different sectors, and lots of different materials. And she's really passionate about trying to find ways that construction really can move in this direction of becoming regenerative. She's worked throughout her career to complement structural design with research, and most recently, inspired by her work on the Eden project up in Dundee in northern Scotland, Elsa got funding from the Institution of Civil Engineers for a piece of research that she did on behalf of Expedition, who she works for, into the embodied biodiversity impacts, embodied ecological impacts of construction materials. And that document, despite being a year old, is something I still find myself referring to people on almost a weekly basis. We will then hear from Kai, who works for UK Green Building Council. Kai is a sustainability professional. He has an expertise in nature, resilience, and circular economy. And he talks a lot about systems level change, and particularly through cross-sector collaboration, which I guess is what UKGBC are so well known for. Kai champions regenerative, nature-positive built environments based around addressing the industry's biodiversity impacts. And he's working with industry professionals to minimize resource use by supporting built environments to shift from a linear economy to a more circular one. I should also say that in addition to that, Kai's work promotes urban nature-based solutions and their multiple benefits. So a lot broader than just a building and materials, but they complement each other. And recently I went to an event organized by Kai, which is a whole day workshop around this topic for industry experts. And I came away from that having learned all sorts of new things. And we're going to hear a bit about that later from Kai. Last but not least, we're joined by Lawrence, who is Chief Operating Officer of the Wildheart Trust, which is a charity set up to rescue exotic animals from pretty horrendous conditions across the globe and give them a safe space to rehabilitate at the Wildheart Animal Sanctuary on the Isle of Wight. So if you're ever down on the Isle of Wight, do go and pay them a visit. In addition to this, the charity spearheads native species conservation work across the UK, and it ensures that its operations are as sustainable as possible. So we've invited Lawrence to speak to you with the sort of client hat on, because the work he's doing at Wildheart, they really care when it comes to their buildings and their built projects about doing those in a different way and in a more sustainable way. And I think there's a lot we can learn from that. Frankly, what's being built at the Wildheart Trust it's super cool. So we're really honoured to have Lawrence join us tonight to be able to talk about things like their bamboo rescue domes, their recycled mountains for big cats, and so on and so forth. So those are your three speakers. I'm going to sit back and listen in the same way you are, and I'll be back on at the end to lead the Q&A. But in the meantime, I'm going to hand over to Elsa, who's going to start you off by telling you a bit about the work she was doing at Expedition. Elsa.
Thanks, Will. Hi, everyone. So I've been thoroughly introduced, and so is the project, really. But I'm here to talk about this piece of research into embodied biodiversity impact of construction materials. It was co-funded by us Expedition at the Useful Simple Trust and the IC's R&D Enabling Fund. And like Will said, we released it about a year ago at the same time as the UKGBC released their research into embodied ecological impacts that you'll hear about very soon. And I wanted to start by saying one of the things I have found in the year since we launched is that people have pretty good, it's quite an intuitive term, people have a pretty good sense of what you're about to say once you've used the term embodied biodiversity impact. And so that risks making me redundant, I think, for the next 10 minutes, although it's a real strength. But if you're one of those people who kind of knows what I'm about to say or has even heard it before, then I hope it's useful. I'm going to talk through the kind of problem statement and the thinking behind the report, and then do a really whistle-stop tour of the report, which you can go and look at later. But with the idea that that might help you spread the word and talk to colleagues and clients about it. So first thing, in 2019, Expedition signed up to the Structural Engineers Declare, and I'm sure many of you from organisations who did the same thing. And when we did that, we declared both a climate emergency and a biodiversity emergency. And as an industry, and maybe as individuals too, we've kind of got to grips somewhat, or at least we understand how we're going to think about carbon and work on it together to reduce it. But biodiversity is lagging a long way behind, and there's a lot of catching up to do to understand it in the same way. And that kind of conversation coming around to biodiversity is happening globally. This is a statement from the UN Secretary General taken in 2022 at COP, and he points specifically to construction as something that has to, as an industry, that has to think about its impact on nature and biodiversity. So it was this kind of context that inspired this piece of research, and as Will said, on our work on the Eden Project Dundee, thinking about regenerative design and how we can benefit the world with that project. And we kind of came up with a concept of embodied biodiversity impact and focused on that because we know that biodiversity on site is beginning to be understood and measured and legislated through biodiversity net gain. But in the same way as carbon, we have no idea what is happening before our materials come to site. And so that's what we were starting to get a handle on in this piece of research. So we know, I think intuitively, that construction must have a big impact on biodiversity. This is the largest quarry in the world. It's not in the UK, but in the UK, we use 37.5 million meters cubed of concrete. And the global consumption of concrete is set to increase in the coming years. And for concrete, we need to quarry limestone and aggregates unless we're getting them recycled. We know that the UK construction industry consumes over 800,000 tonnes of steel per year, and that steel production is an energy and chemical intensive process. It also requires mining for raw materials. This is an image of a dam, tailings dam in Australia, which stores the byproducts of mining. They are highly toxic and potentially radioactive often, and I think this image really makes it look that way. And then finally, timber, which we're increasingly relying upon as a kind of low carbon solve. And we need to think about the biodiversity when we're doing that too, because it's often grown in monocultures, or historically has been. And if it's not certified for sustainable production, then it may still be. Even in that case, it takes a lot of land, and that has an impact on biodiversity. So whichever material we choose of those three, at least, we're going to be impacting biodiversity, and we want to find ways to reduce that impact. So taking another step back, why is biodiversity important? Why should we care about it? It underpins the resilience of the ecosystems that we depend on. There have been efforts to understand the monetary value of biodiversity globally, and they're estimated around $33 trillion per year. But that list on the slide is taken from the 2021 Dasgupta review, which drew out 5 sources of value provided by biodiversity. And they read to me both as giving us life and giving us a reason to live as well. So biodiversity is just absolutely essential to humans and our well-being. But biodiversity is in crisis. We've entered our 6th mass extinction event. This is the first caused by human activity, and previous mass extinction events have wiped out 95% of ecosystems, and it can take millions of years to recover. And as Will said, the UK has led the world in biodiversity destruction. We're one of the most biodiversity depleted countries in the world. And the built environment is a significant contributor to the crisis. The World Economic Forum identified it as one of 3 systems responsible for over 80% of global biodiversity lost. And infrastructure in the built environment impacted 29% of threatened and near threatened species, which means that the places we're getting our materials from are happening in sensitive areas where there's biodiversity that really needs to be protected. And whilst we're beginning to understand the effect of biodiversity on site, similarly to carbon, we have no idea what's under the waterline in this analogy on the slide. All the materials that make up the assets that we design and deliver, concrete, steel, timber, earth and asphalt, require raw materials to be extracted, manufactured, transported to site, and then managed at the end of their life. And there are impacts at all of those stages that we don't yet understand very well. And comparing to carbon, we need to think about the whole life cycle. A key difference in the kind of circles on this diagram is that carbon emitted anywhere in the world contributes to the global problem of climate change and global warming, but biodiversity has a much more local effect. It matters where you're creating the impact, what's there, what the systems are around it, and that introduces a degree of complexity that doesn't exist in carbon. And so we're going to have to think even harder than we did with carbon to begin to be able to quantify this. And we're a long way off from that. So our report kind of draws out qualitative thinking at this stage. But I want to say that similarly to carbon again, as practitioners in the built environment, we can influence the biodiversity impact of our projects through the decisions that we make about the materials that we're designing with and specifying. And considering biodiversity is going to be a really essential part of becoming a future-facing profession. So just very quickly on our research, we wanted to draw out useful conclusions for the construction industry as early as possible, and we knew that a context of lack of data was likely to be the case. So we've looked at the problem through this COM-B model lens, which is capability, opportunity, and motivation needed to make behaviour change. And we intended that would help us draw out kind of practical actions that people can get to straight away, so we can start reducing our impact without having all the numbers behind it. And to kind of frame the research that we were doing, we adopted the UN's 5 biodiversity pressures because we wanted to pick up existing frameworks and understanding wherever we could. We didn't consider the 5th one, which is climate change, because we felt that carbon kind of covered that already in our understanding. We wanted to try to focus specifically on biodiversity. So that's why we've only got 4 on that slide. But for each material, we used those 4 pressures to do the following: define the assumptions that we're taking, we mapped the life cycle, we looked at evidence that was available for how that material affects those 4 UN key pressures. And then with the help of a biodiversity expert, we rated the severity of the impact in each of those areas for each material. We then summarized it with a page like this for each material. And the diagram on the right, this is a relatively simple one because concrete supply chain is a bit shorter and more local than some others. And that summarizes the ratings that we were able to develop with the biodiversity expert. We also wanted to set out some steps the industry could take and start to think about how we could progress our understanding of this. We know it took decades for embodied carbon to move from research into practice. And so this is a very long-term view that we're taking. In the meantime, we pulled out some high-level industry actions that we can all start taking now. They're focused around reducing extraction of raw materials, or else ensuring that extraction is done responsibly. And to do that, we need to understand our supply chains. And so this is our kind of key takeaway that we'd like you to think about when you're working on your projects. But we, on reflection and in discussion since we've launched, we actually think this the iStruct's hierarchy of net zero design is a really complementary approach that will reduce both carbon and biodiversity impact in materials. So we've been able to reproduce this with permission from the iStruct, and we would urge you to always refer to this when you're working on your projects. So that's my last slide. If you want to know more, please have a look at our report. It's available online. And the other place I always point people to is the UKGBC's work on ecological impacts. And fortunately, Kai is the next speaker, so I'll let him tell you about it.
Thank you very much. What a smooth transition. Let me just wait until the slides up. Fantastic. Hello, everyone, from my side as well. I will be talking about embodied ecological impacts, which is essentially the same as embodied biodiversity impacts as Expedition call it. We just call it something differently. We released our main bit of work on this back in September 2023, because similar to Expedition Engineering, we just realized that there's a lot of awareness on biodiversity on site, but not really on the sort of embodied side of things. So the main objective was to raise awareness. We did this as a website because we thought launching a report kind of with a topic that is so nascent and so quickly evolving feels like it's outdated very quickly. So we chose to do a website, and we chose to do it in a very interactive way. So I'm firstly gonna run you a little bit through the content on our website and what it is, and then I will update you on the most recent developments. Will already said it, the conference that we had 2 weeks ago. So you will get the latest insights hot off the press on that as well. So this is part of the website. What you can see here, there's a lot more information on it, but I think one of the key things is this map. We created this global map of extraction sites and location. And what you can see here in light green, this is what we call biodiversity hotspots, or not we call it that, it's a scientific concept. Basically, areas of high level of biodiversity that are at the same time under threat. And you can also see the link here, so I'd encourage you to go to the website and have a look at all the content there. So if you go there and if you look at this website, you'll see this map, and then you can click on these filters and basically toggle on and off different materials. So we chose to look at raw materials here because that's what is actually extracted from the earth. So you can see we looked at iron ore, cement, timber, aluminium, and aggregates. What you can do then is just toggle them on and off and see what's happening. This, for example, is iron, and for each material it shows you one thing, what are the main countries where this is extracted from on the planet, but also then you see these little white circles, which is then an area where extraction happens more concentrated within a certain country. So let's say we click on one of these circles in Brazil, then you have this little blue pop-up coming up with a little bit of extra information. So in that case, you can see that there are a lot of mines in the Pará state in Brazil, including the world's largest open pit iron mine in the Serra Norte complex. And then you can click on Learn More, and that will then take you to a more detailed content page on each of these materials. You find a lot more information there, but this is one of the key bits here, the key impacts for each of these materials. So I'm just going to spend a little bit of time here to make us aware of what we actually mean when we talk about embodied ecological impacts, with the example of iron in that case. So if we extract iron, it is pretty much always an open pit or surface mine. So that means we need to take whatever is on the surface, we need to take that away in order to get access to the ore that is underneath. Now, that means we need to remove all of the topsoil and the existing biodiversity that is there. As you might have seen on the map before, iron mines unfortunately happen to mostly be located in subtropical and tropical areas with a lot of biodiversity. So just the pure fact that we need to take the topsoil away and dig up that material has huge impacts in terms of habitat destruction. The second one here, associated infrastructure. So what that basically means is because these areas are so remote, you need to get to that. So that's then a matter of creating roads, creating railway, power lines, but also power plants in order to get the necessary energy for that. So all of this comes with huge impacts, comes with fragmentation of habitat and much more. And then at the same time, because you have workers going there, you then create settlements, you make this area probably a lot more populated than it was before, which then in turn comes with a lot of other impacts such as pollution, further resource use, waste, all of that. Water use, another big impact, embodied ecological impact when it comes to iron ore, and then contamination and pollution of soil and water. Elsa has just shown you this image of this tailings dam, this big red lake, basically. It's a lake of very, very toxic material, and they have been known to break these dams with catastrophic impacts as well. So it really is some nasty stuff in these tailings dams. So that's just a little bit of an example of the type of information that you can find there, and just illustrating what we mean by embodied ecological impacts a little bit more. So if you then go through the website, we also explore solutions there. In that case, for iron, most of these impacts happen through extraction. So using reused and secondary steel is a good option to avoid this in the first place. So these are some of the solutions that you can find there. And then I said this in the beginning, we set this up as a sort of mostly interactive website, and we call it a knowledge hub as well. Because all of this is so fastly evolving and no one really has a lot of the answers that we need, you can find these yellow buttons all over a website. So I invite you, if you go onto this website and read through and have any information, any questions for us, please just reach out. It's really, we are at a moment in time, I think, where we really need to collaborate together, and that's one way of doing it. So please reach out to us on this. So that's basically what we have published a year ago, and we continuously update that as well. But as Will said initially, we had just 2 weeks ago, we had our conference on embodied ecological impact, and I just wanted to share some of the key topics that have emerged there, and some of the key learnings that we had. It was a conference of 100 people, which is great, and 100 people in London coming together to discuss this topic. We structured the conversation mainly around 3 different topics, which were the engineer's perspective, how to integrate it into projects. Secondly, it was about metrics and data, and lastly, what we can learn from other sectors. So let me just run you quickly through some of the learnings that we had. The engineer's perspective was a really interesting one, because we basically acknowledged that we don't really know a lot of the things that we probably should know in order to make a difference and go to a positive future. So we don't often know where our aggregates come from. We don't know where our sand comes from, whether it's coming from a quarry on the land or whether it's dredged from the sea, which one is better or worse for biodiversity. So many things that we don't really know and we should know. So what will be the next steps? We definitely need more research on that. We have so many people now working on this, being interested in that. So we are currently at UKGBC in a process of thinking about how we can coordinate this potentially with the industry. So everyone's doing a little bit of research, and then we come together and compare notes, basically. And also, it's a matter of reaching out to industry, to our supply chains, and ask the right questions to get this information that we need. A little bit of a call to action here. I'd encourage everyone to bring these conversations to the table. Go to our website, go to the report that Elsa just shared to arm you with the basic knowledge that you need to bring this up in project design team meetings, etc. And yeah, just put it on the map. And we know it's a really, really complex issue. So as Will also said at the conference, just try to focus on one material and try to understand that, and that would really help a lot already. The next topic that we've discussed was metrics and data. Also, really, really interesting one. If you have followed it all, what has happened at COP16, the biodiversity COP, or in the international nature and biodiversity conversations at the moment, you will know that there's a lot of talk around metrics and data and how to use it, and what metrics and data we have and what's lacking. So we wanted to address that as well. It is really tricky because, also, as Elsa said, it's not just about measuring the one molecule that we release in the air that has a certain effect on the biodiversity in nature side. It is a lot more complicated because everything's so localized. So basically, we identified that there was no real consensus on metrics and data and calculation methods, like how to really numerically assess the impact that we're having. Is really difficult, and we don't have consensus on that at the moment. So we really need to advance our understanding of the data, and there's a lot more research needed on this. But one thing that I think is really important here is that let's not focus too much on the data at the moment. Let's focus on what we know, because there are many things that we know that we can do. For example, if we know that digging up these materials, that extracting it from the crust of the earth has such big impacts, let's try to avoid that. Let's use the circular economy. Let's use less stuff. Let's cut out the virgin material as much as we can. So use the mitigation hierarchy, similar to what Elsa also just brought up under the mantra use less stuff. This is very similar. This is our version of it, but whatever you use, it comes down to the same thing. Basically, prioritize the best use of your existing assets, refurbish if you can, reuse materials. If you can't find reused materials, recycled materials, basically do everything you can to avoid the virgin material in the first place. I think that was a really, really powerful message coming out of the data and metrics panel. So let's focus on that first, while at the same time try to get the necessary knowledge on the data side. And then lastly, learning from other sectors, we basically acknowledge that if you look at agriculture or fashion, for example, their supply chains are set up a little bit differently, and there's a lot more traceability in our supply chains than we have here in the built environment, where we have a very low traceability. We've also got high diversity of materials and very different parts of the supply chain. You've got main contractor, you've got subcontractors who might subcontract things out even further. So it's really difficult to get a handle on this. And also the project-based approach that we have in the built environment might complicate the building of long-term relationships with our supply chain, which is a lot more common in fashion and agriculture, for example. So we had some really interesting discussion there. For example, what would a sustainable apparel coalition look like in the built environment? It's basically a group of people, organizations coming together to maximize information sharing and supply chain transparency. What would that look like in the built environment? Or what could we learn from the farm to table approach in agriculture and food? How can we bring this to the built environment? So there's a lot to think through and learn, and next steps for us. And I think, again, call to action, what can we do is just, I've said it before, engage with the supply chain, ask for this information. And also one thing that was mentioned is making use as much as we can of existing certification for product and materials. And that is all I wanted to share at this point. And just to mention again, if you're interested in this, if you've got any information that you think we should have, reach out to us. My email is on the screen, or reach out to us via our website. So yeah, thank you very much. And I'm now handing over to Lawrence, and I'm really interested to about what you have to say. So I will listen very attentively. Thank you very much, Lawrence.
Brilliant. Thanks, Kai. Hi, everybody. So my name's Lawrence. I'm Chief Operating Officer at the Wildheart Animal Sanctuary, which, as we heard earlier, rescues all sorts of animals from around the world. But we also look at all our operations and see how we can do them as sustainably as possible. And that includes the construction of the habitats which we put these animals into. So I'm going to chat today a bit about our approach to this and how we've gone from small scale projects to ultimately some huge construction projects here, using some basic principles that we look to, and when we go out to tender, what we look to do with the engineers we speak to. So firstly, zoological construction has mainly been concrete and steel over the years, and sometimes that is essential with animals like rhinos and elephants. And I've certainly been stood the other side of a steel wall with a very angry 6.5-ton bull elephant, and sometimes you need such materials to maximize the safety. But there's plenty of species that we can use alternative materials for, and methodologies in our construction and our approaches. And I've been part of many discussions around the UK at different zoological industries, where the main decision, sort of final decision, comes down to cost, basically, and people discuss how they can build something that will keep the animals in for as little money as possible. And it comes from a good sort of basis in the fact that the less you spend on the initial construction, the more you can spend on caring for that animal when it's with you. So I get it. It's a little bit old-fashioned, because actually building the right habitat in the first place is one of the essential parts of animal care. So investing in naturalistic materials and creating this amazing home is one of the key features. And we felt that actually the zoological industry should lead the way and showcase latest construction methodologies, because then we can apply pressure on other industries to follow suit. And in particular, at the Wildheart Animal Sanctuary, we're quite a small organization, and we feel if we can do it here with our limited budget, then there's no excuse that bigger charities and organizations couldn't follow suit. And what we wanted to do was show that you could do it for comparable prices. So we started with sort of smaller projects, and we came up with a bit of a hierarchy of how we go about our builds, if you like. And the first one is reusing and repurposing materials wherever we can. And that ideally is from our own site. And we've actually recycled entire buildings into new buildings here, which is brilliant. Not without issue, of course, but it means we didn't have to buy any materials at all, brand new. Will chatted at the start about our recycled Lion Mountain, which I didn't put a picture in of, but basically we had a lot of old cars, fridges, wheelbarrows lying around, and rather than sending them off to landfill, we piled them all up, we covered them in earth, we planted bamboo and trees and native species, and then about 6 months later we were able to put lions on top of them. So they now live on top of this sort of garbage mountain, if you like. And the best thing about it is we've chatted about biodiversity. The honeycomb structure of that landfill nature underneath there is fantastic for invertebrates and small reptiles to live in. So it's vastly improved the biodiversity by using it in that way. What we've also discovered is a lot of what people throw away is very usable. So we trawl the local kind of builders' yards and manufacturers, and we find they've often got stacks of materials in the corners of their yards that they have deemed unusable. So in this picture, of course, the tin, this was stripped off a local barn, was going to be scrapped, and we said, we'll take it. We repurposed it now into a number of fence lines around the site. And the frames we've used for it is all timber that was going to be chucked because it had warped in storage. So the builders' yards we spoke to said it wasn't suitable for the industry. Well, in fact, in a zoological setting, straight lines are a negative. Nature isn't straight. So having wood that's warped is absolutely fine, and we can use it. And then all the glass panels that you can see, these were those panels that the customer ultimately didn't want. These were glass panels that were slightly cut incorrectly. And again, they were just stacked up and with no purpose. So we recycle as much as we can, and going to as big as old shipping containers and old industrial fridge freezers for houses for animals and for visitor lookout spaces. Where we can't recycle and repurpose, we do look for, obviously we have to buy some materials new, and we look for natural materials. For us, that is, we do use wood. We try and get it from sustainably sourced timber, but we also use bamboo. And where we're going at the moment is actually living structures. So we want to do living fence lines to keep the people away from the wild animals. So actually plant fast-growing species that will quickly create those fences. And a project is to do a living playground out of fast-growing species, which will change every year. So it's constantly interesting. Where we can't use natural materials, we will look to reduce other materials, as has been discussed today, as much as possible. And we also consider the lifespan resource use of whatever we build. And in actual fact, the zoological industry is quite old-fashioned. When it comes to housing animals, they use a lot of concrete because there's this old sort of Victorian myth that they have to be kept in sterile environments and scrubbed down with disinfectant every day to ensure they don't get diseases. Well, if you've ever stepped outside your front door, you'll see that the world is full of millions of microorganisms and rotting vegetation and soil and plants. So animals are well capable of living surrounded by these microorganisms. So we've replaced concrete floors with soil. And instead of washing them down with thousands and thousands of liters of water every day, we put in earthworms and woodlice and springtails that eat the urine. And all we have to do is pick up the feces, and that gets spread on a local farmer's field. So it's completely and utterly circular. Away from that sort of more traditional thought processes, insulation, not heating, and powering our buildings using renewables wherever we can. So we've done a number of sort of smaller projects like that. We also do a bit of artwork with it because part of our remit is the behavioural change piece, and it's absolutely phenomenal. Plastic, away from construction materials, the amount of plastic out there is phenomenal, from microplastics all the way up to big stuff. We're right on a beach here, so the sort of structures you see here was plastic that washed up on our beach here over the course of a year, and it's been bound together with other waste materials, including tents that were discarded at the Isle of Wight festival. So it's got a great story for our public, and it helps them to see how they should change their behaviour to have a minimal impact on the planet. But to create proper change, we realised we'd have to scale these thought processes up and prove that we could actually build something on a huge scale that was sort of more akin to traditional construction in other industries. And the chance came along when we wanted to redevelop our primate rescue facility. So this was a huge construction site. It was 35% of our entire sanctuary footprint. And we approached it with that same ethos of reusing where we could, natural materials where we couldn't, looking at biodiversity increase. And we created these amazing geodesic bamboo domes. And in fact, these are the first bamboo structures in the UK that public go through that have got building regulation approval. So they're absolutely amazing. If you're ever down on the Isle of Wight, certainly come along and have a look at them. But applying those principles that we discussed earlier, firstly, the reuse and repurpose. So one of the houses on this development, which is the one in focus and top left of your picture there, that's recycled. That used to be a tiger house that we no longer use. So we knocked it down. We got volunteers to chip off all the render, and we recycled several hundred blocks into a new house that we built for lemurs. So now it's rescuing primates instead of rescuing tigers. The pathways that surround the area, there was an old swimming pool being demolished locally, so we had all the rubble from that, and we used that for the base of the paths, which is really cool because you get lots of little coloured tiles in it as well, so it's quite nice to look at. The walkway which you walk under has telegraph poles that support it that came again from a tiger facility. Before that, they were in a lion facility, and before that, they were telegraph poles. So this is the fourth reincarnation of those posts, which have had different uses every single time. And then the tin that we used earlier, we used to clad the buildings that were already in the area to theme up as a Madagascan village, which was actually perfect. And really interestingly, we're talking about impact around the world. If you go to Madagascar, a lot of the villages are built on recycled materials, which is absolutely fantastic. Where we couldn't recycle was obviously building these amazing outdoor habitats to put the lemurs into and the rescue primates that we were going to get. So we wanted to come up with alternatives to concrete and steel, which are those traditional building products. When it came to the house, we found a lot of data out there actually around construction methods, because it's been used in a domestic setting quite a lot and commercially, things like cob buildings, things like straw houses. So we built the house from 102 bales of straw, which is fantastic as well when we talk about the lifespan resource use, because it is so insulative. But actually, the containment for the primates outside was much harder, and we struggled to find a replacement for steel. And we happened upon a company that built bamboo domes that you could get married in, and we set them the challenge of building a bamboo dome sort of at scale to house primates, which they absolutely leapt at. And this is 777 poles of guadua, I think I've said that right, bamboo, that has grown for 5 years, has obviously sequestered a lot of carbon whilst growing. And then laid end to end, it would actually stretch 2 kilometers. There's a tremendous amount of bamboo here. And it's unbelievably strong, and it enables us to span 25 meters, 12 meters high, without having to have any supports. So it's also fantastic to look at as well, which is fantastic for our visitors. And then going to the reducing non-sustainable materials, there were elements of the build where we had to use things like concrete. But what we did is we sat with our building regs officer, we sat with the construction manager, and we applied a rule of common sense across everything, because the initial architect's drawings had foundations that you could put a multi-story car park on, and we were putting straw on top of it. So we came to a mutual agreement using that rule across every touch point of reducing the materials down, so they were still happy, they were safe, but they made sense for what was being built. And we actually reduced by about 60% our use of these, what we would call sort of non-sustainable materials like concrete. We'd actually like to build a house with no foundations at all. We've not found anyone brave enough to help us do that yet, because for us, it doesn't matter if it shifts a bit. The animals won't care. So why don't we just build it straight onto the soil? It's much better. And then we could even have plants growing in it as well, and all sorts of amazing things. So that's the next step we want to go to as well. And then within this building, we have a living floor, so we don't use any water. The straw is an excellent insulator. We put a living roof on top of it so that it increased biodiversity, and also we coupled that with planting native species to the area throughout the entire project. And we did studies before and after, and the build increased the biodiversity absolutely no end, which was fantastic. And then we offset the running costs of the building by putting in solar panels everywhere. It was a steep learning curve for us. What we did find, though, and we were able to prove that at scale, this whole project cost less overall than traditional building materials and methods, which was amazing. Like for like, the bamboo domes were only £100 more expensive themselves than the steel that was originally costed up. And the lack of over-engineering, because in the zoological world, when people don't understand animals, they tend to triple up on the amount of steel and triple up on the amount of mesh that's needed. And by not over-engineering it, so it was fit for purpose for primates, we reduced the amount of harmful products that we used. The barriers we hit during this sort of build was we found it hard to get an engineer to do the structural calculations on the bamboo because it hadn't been done before, and we had to go internationally to find that support. There was a huge amount of nervousness around the recycled materials, and I said we recycled the entire building, which was fantastic. The original building was much bigger, so the blockworks that had been selected for it were at a very high spec, over-spec for the building that we were going to build. But even with that, the building control weren't happy on the corners of the building or over the doorway that we could use recycled blocks, because we couldn't find the data or any sort of evidence that it was fine. So we did have to buy some blocks in new to support the recycled ones we used. So we talked about data and metrics. Any information about recycled materials and the lifespan of them would be brilliant for people like ourselves. And then really interestingly, when dealing with bamboo, at one point we had a supply chain issue, and we were going to switch species and supplier, which meant the species would switch. And the building reg said if we switch species of bamboo, we had to go right back to the beginning and do all the structural calculations again. So what would be useful, again, from a client's point of view with something like bamboo, if similar species with similar sort of tolerances and properties could be grouped to give the client choice to switch out and switch in different species without having to start the project again, because it was quite a serious issue at the time, because it was going to set the build project back a number of months. So there was a few hurdles along the way, but actually what we ended up with was this amazing, what we call sustainably built ethical habitat, which is fantastic for the animals within it, which ticks all the boxes from a safety point of view, and has actually encouraged and increased biodiversity of native species in its construction locally as well. So that's a bit of a whistle-stop tour of some of the things we're doing here. The next project is Bears, which we're working with an amazing company to redesign that house, minimize the concrete, and we're recycling all sorts of materials in its construction as well. Because if we can keep bears in like this, then that's a really powerful message to go out to the industry with.